So in this module, we are going to see about the collisions avoidance system. So the last module deal with various parameters where the last section was variable speed limit. So based on the speed, different collisions can happen. So in this module, let us see how the collision avoidance systems can be taken into place. So this technology was first installed by Japan, where they have installed the sensors on the highways to notify the motorists that the car is being stalled ahead. So this is a technology which has been installed by Japan with different types of sensors on the highways. So in this technologies, the RFID was used, which is nothing but the radio frequency waves, which was used for dynamic traffic light sequence. So in by using of this RFID for the dynamic traffic light sequence, basically there are some problems that arise with the image processing and the beam interruption techniques. But by using this RFID technology, it has an appropriate algorithm and a database which was then applied to the multi-vehicle or a multi-lane or a multi-road junction, which provides an efficient time and management scheme. So that is why this RFID is very much useful rather than any complex algorithm or image processing technique. So this dynamic time schedule was worked on based on the passage of each column. So this here the simulation showed that the dynamic sequence algorithm will adjust itself even by the presence of extreme cases. So in the peak and non-peak cases also, the dynamic light sequence works very properly by using with the help of the RFID. So this system could be used for the judgment for the traffic police or the officer who is on duty by considering the number of vehicles in each column and the routing properties. So basically this is the RFID is very much useful when compared to other image processing and beam interruption technique, as it can take the decision by itself in the extreme cases as well. Extreme cases in the sense the congested situations also. So this is how the dynamic traffic light sequence look like, where the different type of sensors has been used to see that whether a vehicle is being coming from any direction. So this is basically used in the night direction in order to identify whether a vehicle is coming from the opposite direction or the vehicle is moving in a wrong side direction. So that is why there is a role of this dynamic traffic light sequence, which uses the RFID type of data for capturing a huge amount of data. So in order to ensure safety during the night times as well as on the day times. Next, let us see what is this cooperative systems on the road. So basically the cooperation system is nothing but we are able to incorporate a connection from different parameters on the road. So it includes the car to car, so that is V2V, which is vehicle to vehicle, car to infrastructure, which is V2I, that is vehicle to infrastructure, and vice versa. So we are able to generate a communication between different parameters on the road. So the data available from these type of vehicles are basically acquired and transmitted to a server for the central fusion and processing. These data can be used to detect the events such as the rain and the conjunctions. So the server processor, like basically the driving recommendation, which is dedicated to a single lane or a specific group of drivers, and transmit is wirelessly to the vehicles. So here there is no connection basically with the wired one. So it has a wireless connection. So where we are able to generate a communication between different networks or different frameworks on the road. So that is V2V, V2I, V2P. So basically the goal of this cooperative system is to use and plan communication and sensor information or the infrastructure to increase the road safety. So in order to ensure the road safety, in order to prevent the collisions or any type of accidents on the road, this cooperative systems on the road is very much essential. So this is how it looks like. So you can see that different cameras has been mounted on some on nearby on the road on different tripods or the street lights in order to capture different type of information related or the vehicles moving on the road, such that this information will further give a connection between vehicles, infrastructure, pedestrians on the road. So this type of cooperative system on the road is basically very much essential to ensure the road safety. So road operators, infrastructure, vehicles and their drivers and other road users will cooperate to deliver the most efficient, safe, secure and comfortable journey. So this is a goal of the cooperative system, where all the road users who are using the road, that with the different modes of the transport, can cooperate to deliver the most efficient, safe, secure and comfortable journey. So the vehicle to infrastructure cooperation system will contribute to the objectives beyond the improvements achievable with standalone systems. So this type of cooperations is very much essential for ensuring the objective of the road safety. So this is the communication systems on the road, where we are able to meet the communication between different parameters. So if you can see, this is an intersection. At this intersection, different types of vehicles are plying in different directions. So we are able to maintain different type of connection from between the vehicles, between the vehicle to infrastructure, that is the road at which the vehicle can move to any leg of the road, and vehicle to infrastructure, where if any pedestrians is crossing by, then it can also build a communication between the vehicle to the pedestrian as well. So that this is how the cooperative system on the road work like. So moving on to the next parameter or the module, which is nothing but the electronic toll collection. So this electronic toll collection, basically the aim of this electronic toll collection is to minimize the queue length or the delay at the toll plazas. So how can we do that? So with the help of this electronic toll plaza collection in this ITS application, it allows a toll payment without stopping of the vehicle. So we are able to pay the toll without stopping of the vehicle for a longer period of time. So this electronic toll collection, it uses different frequencies of the radio for identification, that is nothing but radio frequency identification, RFID. It uses a dedicated short range communication, and it also takes into consideration the automatic number plate recognition. So speaking to one by one, in this ETC, which is electronic toll collection, whenever the vehicle is approaching the toll plaza, so the transponders which is there in the toll plazas, they are hitting the barcode which is there on the vehicle, such that some sort of radio frequency identification is happening, and then after hitting the barcode, some information is being sent to the bank, and from the bank the amount is being detected, that is a toll amount, and then the boom which is there at the toll collection is being lifted up within a very short period of time. So all these things or all these works happen in a very short period of time, so without stopping of the vehicle for a long period of time. So the benefits of this ETS, it includes like it reduces the congestion at the toll plazas, it lowers the fuel consumption, it also leads to improved revenue collection efficiency and enhance the user convenience. So in order to basically stop the delay and the queue length at the toll plazas, so without waiting for long period of time, this type of electronic toll collection will ensure that the vehicle doesn't stop for a long period of time, and the level of congestion or the delay get minimized at this type of toll plazas. So next, moving to again some more information on this electronic toll plaza, where we can see in the picture, like as soon as the vehicle approaches the toll plazas, different types of sensors and some tags will be there, some pass tags, that is nothing but the EZ pass tags, through which some sort of information is taking place, some cameras are being monitored, and then some information is sent to the bank account of the user, from which the amount has been detected as a toll amount, and then the information is being received by this toll people plus persons, and then the boom which is there, it get erected out, the traffic get erected out, which are causing much any sort of delay. So today most of these toll plazas are equipped with electronic toll collection system. So basically it uses the EZ pass that detect and process the toll electronically, so automatically all the operation take place, and it has eradicated the use of manual collection of the toll. So this E-Pass uses a vehicle mounted transponders that is activated to an antenna on the toll lane. So whatever the information is there, the account information is being stored in these transponders, and the antenna which is being fixed over here identifies your transponders and read your account information. So the amount of the toll is being detected and you are allowed through. So at the last, the boom barrier which is there get lifted up, the traffic gate lifted up after detection of the amount without taking much delay for the vehicles to stop at the toll plazas. So this is how it looks like. These are the antennas. This is the EZ tags, and there are some sort of ID, IC cards, and some mutual wireless communication take place. As soon as a vehicle enter the toll plazas, some sort of information is being taken out on the tags, some radio frequency signals, and again it is moved and into the antennas where the toll get detected, and finally the vehicle moves out without any stopping for further delay at the toll plazas. Moving on to the next module, which is the emergency management services. So emergency management services are greatly enhanced by the traffic control centers that continually monitor the roadway condition. So it is a type of a rescue where the emergency management services are essentially required on the road. So why is this emergency management system required? So what are this emergency management system? So emergency management systems are basically required if any accident or collision had happened on the road. It can be a mid-block section, it can be at the intersection, or it can be any expressways, urban arterials, or different categories of the road. So at these type of road, the emergency management system for the accidents as well, or any type of vehicle has breakdown on the road, or a different type of rescue or the fire operation to be carried out onto the nearby community. So for that, the emergency management services are being required. So these type of systems, they continually monitor the roadway conditions. So basically, whenever an incident occur, the nearest emergency service vehicle is located electronically. So here, suppose an collision has happened on the road. So the nearby emergency vehicle should be located electronically and should move out to the scene. So in the sense where if there is a minor collision or a major collision, this system should communicate electronically and send some sort of signals to the nearby police station as well, to the nearby hospitals as well, where an ambulance should be ready and it should come to the scene or the site immediately without any further delay, such that the life of the patient can be relieved and for the life of the patient can be saved. So here the highway managers then alert the other traffic drivers. So basically, if any sort of signal has been sent, the highway managers who are taking the care of sending the information to the emergency vehicle systems, so they should send the dynamic message sign. So taking that sign into consideration, they should respond properly and respond very early, such that they can help the life of the people and reduce the occurrence of secondary incident. So that is why the emergency management services plays a very important role. So this is an emergency management service wherever any collision have occurred. So basically the collisions, when we talk about, they can be different types of collision, that may be rear end, front end, and swipe end. So in order to combat these type of collisions or onto the road, or in order to have so the ITS applications are very much essential. So here the emergency management system, which is one of the application of ITS, plays a prominent role. So where the signals where different, if any sort of collision has happened, they move in a timely manner such that they can save the life of the patient. Next, moving to the next parameter, which is ITS and the road pricing. So this is one more application of ITS where the advanced road pricing mechanisms takes place, where the users are charged based on time, location, distance, and congestion level. So as we can see that many of the Indian cities are heavily congested, like the Bengaluru, Mumbai, Pune. So these are heavily congested at different locations. So in order to relieve from that congestion, or in order to have the free flow of traffic at that location, there is the ITS have been included with the road pricing, where the road users should pay a specific related tax or specific related amount such that that can be used for the proper ITS implementation at that junction or that road urban arterial. So different types of road pricing includes congestion pricing. So if there is so much amount of congestion over here, we have to pay the congestion amount. So that is congestion pricing. Distance based pricing. Distance based pricing in the sense basically to travel from one distance to another location, we need to pay a separate specific amount. So basically this is much relevant for the toll pricing. So if you are traveling from one state to the another state, we are paying the distance based pricing for that. A time of the day pricing, what time and which we are traveling, what zone in which we are moving on. So we have to pay a different type of road pricing. So it is supported by the ITS, so which manage the travel demand. So based on the demand of the travel on the road, we can take the pricing which can reduce the congestion and it can generate an additional revenue for the transportation improvements. Next, moving to transportation network operations. So what is this operations? It basically involve the coordinated measurement of roadway, traffic signals, freeways information system to ensure the efficient movement of people as well as goods. So this network communication. So network communication is nothing but it is building a network between the roadway, traffic way, in the sense what it is building a different network with the road infrastructure. Road infrastructure is nothing but the traffic signals, freeways and different information system, so as to ensure that the people and the goods travel in an efficient manner. So ITS application in the network operations include integrated corridor management. So we should have a proper database that how a corridor is being integrated with the another corridor. So real time, because of which we can get the real time traffic control. We should have a coordination between the arterial roads and highways such that a proper flow of the traffic can be moved on. We should have a multi-modal network management. Multi-modal where different types of modes are interacting in a heterogeneous traffic. So as already said that the Indian traffic is an heterogeneous traffic type of traffic where different types of vehicles ply on it. So from the car, from the two-wheeler, from the trucks, public vehicles like as in buses, cycles, non-motorized vehicle, everything move on a heterogeneous vehicles. So we should have a network between those them. So that is called as multi-modal network management. So these applications basically improve the system reliability and resilience. Coming to commercial vehicle operation. So here we are talking about the commercial vehicles, basically the trucks and all. So the freight vehicles which is basically used in the logistic operation. So the commercial vehicle operation, the use in ITS technologies, so in order to enhance the safety, efficiency and regulatory compliance of the freight and logistic operations. So this CVO is required, which is integrated with the ITS. So it should include the vehicle tracking and fleet management. As like the railway traveling, when we travel over the rail, we can track at which the rail is. So like an Indian Railways where suppose we want to go to one point to the another point, we can track the where our railway is there, whether it is delayed or not, which station it has reached. So likewise the GPS is being installed in that type of railways, so in order to track wherever vehicle it is. Likewise for the commercial vehicle operations also, the vehicle should have the tracking system, so where the fleet management is possible, where we can see where our operations, where our different our product is being reached. So that is called as fleet management. So if I take an example of the fleet management, if I take the Indian Post services, so when we go and book our any sort of product, so they give us a tracing number or the consignment number through which we can trace the vehicle where our product has been reached. So that is how the fleet management take place. Then electronic logging devices. So here in the electronic logging devices, we are able to check the different operations related to the logistics. Weigh in motion system. So commercial vehicles basically they carry huge amount of load whenever they are moving from point A to point B. So they should have a control on the way as well. So how to check the way of the commercial vehicles? So as like our speed humpers or the hump which is provided on the road, this is a small type of humps which weigh the vehicle which is in motion. There is a camera being installed over there, and that camera is detecting what is the weight of the vehicle, and finally it is helpful for the freight operations. Electronic credentiality and permits. So like whether it is that fleet or the vehicle or the truck which is moving from one state to another state, it is having any electronic credibility, and whether it is having permit or not, everything can be recorded through this ITS application, which is commercial vehicle operation. So likewise, the commercial vehicle improves the supply chain efficiency while reducing the enforcement cost and the road damage. So in the next module, we'll be dealing with one more application of ITS, which is related to public transportation system.